Good afternoon. I'm Chris Lenhart, and I'm continuing this presentation on balancing ecosystem and human water needs with the part 2 on water quality. Let's start out with just a little outline about what we're going to talk about today. I'll talk about some of the basics of water quality issues, what are some of the pollutants, the pathways for being carried into our waterways, a little background on dead zones, what that means, lake algal blooms, as well as soil erosion, lake degradation. I'll go into a little more detail on a Lake Erie case study, and then wrap up by talking about some of the things we can do to address water quality issues with best management practices in urban and agricultural areas. All right, so what is the problem with water quality and sustainability? What is the conflict? Well, there's a number of issues. In a broad sense, farming in urban landscapes pollute or degrade rivers and lakes for a variety of reasons. We talked about some of that in the previous slideshow about increasing runoff and the flow of water. In agricultural areas, we also need to apply fertilizers and pesticides to maximize food growth, and that leads to pollution of the waterways. Not all that is effectively used by plants or kept on the landscape and ends up in our rivers, lakes, wetlands, and oceans. So in the big picture, we have this conflict about how we grow food more sustainably while trying to maintain the qualities of our rivers, lakes, and oceans that receive the drainage from those areas. So it's a large issue. One of the major themes of this class. We'll hit on it here. Joe Magner, in the week following this presentation, also talks about water quality. There's also a number of these issues are discussed in Gary Sayen's section on the agriculture as well as sprinkled throughout some of the other talks. So first I just want to make the point that water quantity and water quality are linked. They're not like two separate distinct topics. As we mentioned in the previous talk, agricultural land uses tend to increase the delivery of nutrient-laden waters to our streams, lakes, and oceans. So when you get more flow coming off the landscape, either as surface runoff or in subsurface drainage flow, you are carrying just a greater quantity of the total quantity of these nutrients and pollutants. So that it's not just the concentration of the pollutant or nutrient, but the total load of these pollutants that are being carried into the water, because ultimately we have to address these issues. And Joe Magner will go into more detail on some of the Clean Water Act and total maximum daily load issues and regulations. So I'm not going to go into the specifics of that. I just want to give some background on what is meant by water pollution first. So what are some of the most common pollutants? Well, overall, sediment is by far the most common pollutant in terms of just volume of eroded sediment being carried into our waterways. So it's a little tricky with that because sediment in itself isn't a pollutant. It's not a toxic substance, but it has negative impacts on the aquatic environment. It'll fill in riffles, causing problems for fish spawning. Creates turbidity in streams, which creates problems for filter feeding organisms, in rivers and lakes. It also, silts in our reservoirs and canals and things like that. Just in terms of overall abundance, excess nutrients are probably the next most common pollutant in U.S. waterways, which is generally we're talking about nitrogen and phosphorus, which originates either from fertilizer or from just dead plant material. So leaves in urban areas, for example, that get carried in runoff into lakes. Another major pollutant is fecal coliform bacteria. So this becomes an issue where you have, say, cattle grazing or other animal agriculture where the animal droppings can create high bacteria levels, in the waterways. You also can see this even in urban areas or shorelines where you have geese and things like that. It can also come up if you have poorly functioning septic systems in rural areas, for example. Another major pollutant are heavy metals. These are some of the more toxic substances, often from kind of an industrial origin. So things like mercury, lead, and arsenic, which can persist in the environment for a long time, can be found in the sediments or in the bottom of reservoirs, for example. And those are, more serious problems, but they tend to be more focused in certain areas and certainly not in as large of abundance as sediment and nutrients and the bacteria problems. Some of the other, pollutants we have are pesticides. So pesticides are, used in agriculture to control pests and are, needed to, provide, the crop growth and productive agriculture that we need. But they often end up in the aquatic environment, and their effects on the aquatic organisms is a little more, I'd say, controversial, or perhaps a sort of, less agreement. There's less agreement about how much impact they have, and that's really almost a whole course in itself. But I think for here, it's good enough to say that there are some negative impacts on aquatic life, and we try to keep those out of the aquatic environment as much as possible. There's also a lot of what are called emerging contaminants. So there's pollutants that we don't know that much about, which are starting to get into the water. The pharmaceuticals, so some of the drugs, medicines that we use will get into the water and then cause unknown or sort of unusual impacts on fish and other aquatic life. Earlier in the course, I had tweeted out that article about finding the antidepressants in fish in the Mississippi River. So yeah, these things are a lot of unknown things about how much this is occurring, how big of a problem it is. Yeah, and then the next one on this list, the greenhouse gases. We of course know a lot more about this issue, the carbon dioxide, methane, and other gas emissions that contribute to global warming. And so this is a lot more known about this and pretty well established, or very well established, but it's emerging in the sense that it's not regulated in most cases. So it's not regulated in the way that pesticides or metals or even sediment erosion are. So it's not quite there yet on that topic. Some of the other things, thermal pollution has actually been around for a long time. This is putting warm water from industrial cooling plants. So if they need to cool their kind of an energy plant, they'll need water for cooling, and then they'll discharge the warm water into a river. And so that can cause negative impacts. For example, if you have a cold water trout stream, it would degrade the trout stream. There's also excess river flow. So again, this is not commonly considered a pollutant. That's why it's grouped under this emerging contaminants. It's widely recognized that it causes problems for the aquatic environment and creates erosion, for example, but it's not considered a pollutant per se. And so people have been struggling with that issue of how do we classify, excess flow, especially in agricultural areas where it's not regulated. Okay, just a little more background on some of the major pollutants. So sediment, like I said, is the most widespread pollutant by far. And you get, more erosion when you get faster river flows on the upstream areas. You get gully erosion and field erosion or construction site erosion if you're in urban areas. This slide here shows a slumping stream bank in Elm Creek, which is in southern Minnesota, not far from the Iowa border. So you have sediment, erosion coming from a variety of sources, from our activities, but also our direct activities on the land, but also just our activities that have caused increased flow in the rivers and caused more erosion from the channel itself. And then this sediment, causes problems for the aquatic life, as we've mentioned before. One of the other issues with soil erosion is that it also, over time, will decrease the fertility of the soils because you're eroding the topsoil, which tends to be the most fertile, nutrient-rich, high organic matter content, and carrying it downstream into areas where it's not needed. So that impacts the long-term sustainability of our farms. And then that often requires people to put more chemicals, more fertilizers on the land because the soil is not as fertile. So it's kind of a vicious cycle. So plants need, nutrients to grow. The macronutrients are commonly, as they're commonly referred to, are nitrogen, phosphorus, and potassium. You'll see this NPK abbreviation on fertilizers. So it's used in large amounts, in agricultural areas, and in urban areas on golf course lawns and even individual lawns to some degree. Plants also need micronutrients, things like calcium and magnesium, sulfate, and all these things are taken up, by the roots in the soil water obtained through transpiration. But there's typically not enough nutrients to maintain this crop growth year after year, so we apply fertilizers. Not all that fertilizer is taken up by the plant, so you get excess, fertilizer, and in particular the nitrogen and phosphorus is detrimental, which we'll get into more detail in the later slides. This is either carried in the surface water runoff or this subsurface drainage flow. And in farmland, there's actually oftentimes small drainage pipes about this big around that are 3-4 feet down, and they carry extra water out of the soil so that the plants are better able to grow. But that it kind of accelerates the delivery of nutrients, to our rivers, lakes, and wetlands. And one of the ways you can reduce this impact of nutrient runoff is with providing more permanent plant cover. So if you have crops like hay or agroforestry crops like fruit orchards, nut crops like walnuts, this helps to reduce runoff. You can also do things like cover crops. Just keeping plant growth on the soil really helps to reduce runoff and pollution. We'll have a little more of that on the BMP sections later. So nutrients are carried to the waterways either in surface runoff or as dissolved pollutants. In surface runoff, you tend to have the concentrated soil, but you also get some nitrogen, and especially phosphorus is carried that way primarily in the surface runoff. You get a lot of sediment and phosphorus also from gully and stream bank erosion. So a stream bank is on the side of the main bank of a river channel. A gully is a small kind of indentation in an area of farmland or bare soil where you get a channel forming. These areas tend to be hot spots for erosion that create a lot of sediment, and also headaches for farmers or roads or infrastructure or anything that's near them. And the dissolved pollutants, on the other hand, are things like nitrates. So these will infiltrate into the ground and then be carried out in subsurface flow, like the tile drainage, or even in groundwater. These nutrients then lead to excess algae blooms in water and aquatic plant growth in coastal areas, and whichever water areas they flow into. I mentioned the coastal areas here because we're going to have some slides on the dead zone coming up, which occur in coastal areas. But anyway, as this nutrients get carried to these coastal areas or lakes, you get decomposition of all this plant growth. So you get a flush of plant nutrients. The plants and algae grow, and then they die. When they die, they consume the oxygen in the decomposition process. You then have an area of water that has almost very little oxygen and doesn't support a lot of life in those areas. I'll also have some slides on this coming up. This is just a slide talking about this field and gully erosion problem and how the fields become robbed of fertility by poor management, and over time then either have to be abandoned or kind of rehabilitated or just managed a lot more heavily than they were in the first place. This is actually a picture from the 1930s from the original Soil Conservation Service that the U.S. created to help address excess erosion in farmland. So I thought it was interesting to just throw that in there. But so getting back to this issue of eutrophication in the dead zone. So eutrophication is a term for kind of excess plant productivity in aquatic environments. So we often have this picture in our head of this pristine, clear lake where you can see down in the water like 10 feet. When you start getting eutrophication, this delivery of nutrients and extra plant growth, you get algae blooms, and you often, you can't see very far in the water at all, maybe not even past the surface if it's concentrated in the late summer. So yeah, and then in the coastal areas where we get nitrogen carried down into these water bodies, and the nitrogen is thought to be the main cause of these algae blooms in the saltwater environment, because it's the main limiting nutrient in that ecosystem type. So when you flush a bunch of nitrate down into these coastal areas, again, you get the flush of plant growth or algae growth, and then they die and create an area that's referred to as a dead zone, or a hypoxic zone is another term for it. Hypoxic meaning low oxygen. So this map of the world here showing all these dead zone is very kind of concerning when you see just the number of them. These are areas that have been recorded at least for a year or two. Some of them have persisted for decades. But if low oxygen, then which creates areas where not many fish or aquatic life can live, other than like algae. So there's a lot on the east coast of the U.S., Gulf of Mexico, but also in less less well-known areas, or where we hear about it less anyways, in South America. There's a lot in Europe and over in the coast of Asia. The thing that you hear about the most often in the U.S. is this Gulf of Mexico dead zone. So this is where the Mississippi River comes out in Louisiana, carries all these nutrients into the ocean, and you get this eutrophication, plant death formation, this dead zone. It's a huge area. It's like the size of several small states when it's at its maximum. So people have been trying to address that and reduce it, but it's a big problem. Again, mostly driven by nitrate in our water, which gets carried into the Mississippi River and then carried all the way down here. So Minnesota, we're at the headwaters of the Mississippi River. We contribute to this problem somewhat. Okay, so that's a large issue, but in Minnesota, the lake degradation is often one of the biggest water management issues we have, because people like lakes so much. I mean, they go there for vacation and have their lake homes. People are often very concerned and willing to spend personal time and money on trying to clean up these lakes. As we mentioned, they get degraded through excess runoff and pollution. In freshwater lakes, phosphorus is the main problem, because phosphorus is the nutrient that's in the shortest supply, is considered the limiting factor in lakes. So if you all of a sudden dump a whole bunch of phosphorus into a lake that's pristine, you're going to see a flush of plant and algae growth. So then people want to try to control that through various ways, reducing the supply of sediment. Much of the phosphorus is actually attached to sediment, so if you can control sediment, you can control phosphorus. There is dissolved phosphorus too, which you see in agricultural areas in the subsurface drainage, for example. Some of the other lake-related problems, we have man-made lakes or reservoirs, which become filled with sediment, which you mentioned in Mississippi River example earlier. Here's just a picture of some of these freshwater algae blooms from a area that is kind of a mixture of lakes and wetlands down in southern Minnesota. This is showing the area in the fall when you don't have the algae blooms, and this is showing kind of peak algae growth, as well as there's things like duckweed and some plants, aquatic plants, that are more tolerant of kind of high nutrient and low light kind of degraded conditions. So that's kind of what we're trying to avoid, trying to manage for. I'm going to go through an example of Lake Erie, which is probably one of the most famous examples of lake eutrophication and efforts to try to clean it up in the United States. So Lake Erie was thought to be dead. People called it a dead lake in the 60s, and because they had this green algae growth just all over the place, especially in the western part of the basin. So this is Ohio right here. This is Cleveland. This is Canada, Ontario. This is Detroit and Michigan right here. You have a huge area of farmland, but also kind of factories and industrial facilities along the coastal areas. And initially, they looked at these point sources of pollution and found there was a lot of phosphorus coming from them, as well as from water treatment plants. they're able to clean those up pretty well, get control over those phosphorus sources. When the Clean Water Act was created in the early 70s. And it's seen as a big success story. The water quality started cleaning up in Lake Erie. A lot of these coastal areas weren't experiencing algae blooms. You could swim, fish for walleye. It's one of the biggest tourist resources in the region for Ohio and that part of Michigan and Ontario. But what happened is then they kind of forgot about the agricultural runoff, and they didn't address that. It's harder to, because you're dealing with thousands of square miles of land, trying to control the runoff and drainage water, carrying the phosphorus to the lake. So it came back, this problem creeped back up. We started having algae blooms really bad in the Western Basin especially. And just a couple years ago, city of Toledo, which in the metro area is over 1 million people, had to actually close off their water supply. It created this big ruckus. People were, looking for places they could buy bottled water at the store because they couldn't drink the water out of their tap. You see, this is from, I believe, the Toledo Blade, local newspaper there. People were describing, it looking like green paint, pea soup, shamrock shake. So what happened was there was a really bad algae bloom concentrated with a toxic form, I believe it's Microcystis. It drifted over the water intake, so they couldn't pump their water out of there anymore. It created a big uproar. And now people are, again, aggressively trying to solve this problem, although now focusing on the agricultural land use, because again, the industrial and water treatment plants that used to discharge some phosphorus, or still do some, they regulated those and were able to clean those up. But now, so now it's all these attempts to control the drainage from these farm practices. And we talked about these areas affected, the need to balance farm production with clean water. Yeah, so it's a big issue because a lot of these regions get their income from farming, and so we're asking farmers to try to reduce the outflow of phosphorus into the lake. And there's a number of management practices which can be used to control and regulate outflow of phosphorus. This Minnesota Agricultural BMP Handbook, which we provide a link to on the course website, is a good source for detail on what these practices are. And they range from things like plowing practices that reduce the tillage of the soil, the no-till, low-till, to things like grass swales, to treatment wetlands, which actually capture and treat some of the water before it goes into the streams, which then drain to Lake Erie. So as I mentioned, in rural areas, we have these various practices which help control soil erosion and also just fertilizer management. So managing the timing, the placement, the form of the fertilizer in a way that allows them to grow crops, but doesn't produce this excess, which then drains off. You want to apply the optimal amount, that they need to grow, but then you're not going to be getting so much excess waste that's carried off to the lake. And, in urban areas, it's a little bit a different situation, quite a different situation, because most of the area is paved already, so you don't have a lot of bare soil, except at construction sites, which can be a big source, but those are pretty tightly regulated. But there are things like leaves, actually. A lot of the local lakes are doing leaf sweeping to control this source of phosphorus, which is in the leaves, to the lake. There's also things like animal droppings. So on golf courses, you get a lot of geese, which have droppings all over the place, which can also cause bacteria problems. But you have all these sources of phosphorus, which are a little different in urban areas. You also have residual phosphorus in lakes. So, you can clean up everything going into the lake, but many of our lakes have a lot of phosphorus in the soil at the bottom of the lake because we've had, a century of high runoff rates carrying sediment into them. And so that needs to be managed as well if you're trying to clean up lakes in urban areas or developed areas. Some of the practices in the Twin Cities that are being used to control phosphorus, there's actually a phosphorus fertilizer ban for residential lawns with exceptions. If you can show you actually need it, you can get an exemption to apply it. Most of the soils around here have plenty of phosphorus. You don't actually need to apply it. There's the leaf sweeping, as I mentioned. Construction site erosion control is a big, important kind of process to control sediment especially, but also phosphorus. Okay, and then it's kind of linking it back into the big picture of this sustainable water management framework. So yeah, I said with the environment, there's this need to manage the flow levels as well as minimize pollution going into our water bodies. And in terms of economics, a lot of these solutions that we're talking about involve trying to maintain farm profitability while still reducing the pollutants. And so that's tricky, of course, but there are things like precision agriculture, which helps farmers to place nutrients only where they need it, which helps them also reduce wasted cost on fertilizer that's just going to run off. There's things like alternative crops. There's a big effort to push the development of perennial crops, which are crops that continue to grow each year and you don't have to plant them each time, like corn and soybeans. You have to plant them each spring, and then that creates a period of bare soil in the spring where you have a lot of erosion and nutrients being carried off the farmland. There's a lot of research going on that at the University of Minnesota. Actually developed these new crops, which is I think there's a lot of potential. Still not, some of them are widely used, but there's still a lot of work to be done on that. And then, as we mentioned before, the social issues. Trying to find solutions that fit with what the local people want to do and their value systems. All right, I mentioned this agricultural BMP handbook. Here is the cover of this. So this is the Minnesota handbook sponsored by the Minnesota Department of Agriculture. So our department just updated this, and we have it on our website, and it's linked to the course website. There's details on 30 plus BMPs, as they're called. You can learn more about them if you're interested. In a general sense, you can break these up into 3 categories using this treatment train framework, which is where you try to reduce or just prevent the loss of soil and nutrients in the first place from the high ground, from the uplands. So things that cover the ground, like cover crops or no-till, that prevents the loss of the soil and nutrients in the first place from even moving. In between, there's these control practices which kind of slow down or regulate the flow of water, nutrients, and soil. So things like grass swales, which are shown in this picture right here, they kind of slow down or control the rate of loss as it's moving downstream. And then we have edge of field practices which help to trap water and pollutants. These are things like small wetlands or riparian buffers, or which you've probably heard of, bioreactors you may not have heard of. These are small trenches where you put wood chips usually. So they're kind of concentrated treatment areas for water where you run farm drainage through to remove excess mostly those are about removing nitrogen. Okay, so there's a lot of things we can do. Here's just another couple pictures. Grass swale, this is a treatment wetland that we designed and constructed and researched down in southern Minnesota in Martin County that has been effective at removing nitrogen and phosphorus, as well as reducing the flow, coming out of here, slowing down the flow, and then releasing it slowly into the stream. This is Elm Creek, a creek down in Martin County that flows into the Blue Earth River. Okay, so we have a lot of agricultural BMPs. In urban areas, there's also things that you can do. So of course, there's a lot of work being done by the government agencies, the soil and water conservation districts, the watershed districts, the Minnesota Pollution Control Agency, Minnesota DNR, Met Council. All these places are working on, urban water. On your own property, some of the things you can do are things like native landscaping. So in arid areas like out in California or Nevada, this helps to reduce the use of water, so you don't need to water your plants so much. In Minnesota, it's often more of an issue of excess water, so we do things like rain gardens, which is kind of a form of native landscaping where you dig a trench or a hole, and then you route the water that's coming off your sidewalks or roof into this rain garden. It treats the water, stores it temporarily, it drains down quickly, so you have a dry area most of the time. So the rain gardens are something that people are doing and are excited about. You can get information on that actually from a lot of the watershed district websites. Also, more generally, just infiltration practices, so trying to put water back into the ground. You have all this impervious area or areas where water is running off more quickly. So if you can slow the water down and get it to go into the ground, There are things called infiltration basins, which are specifically designed to do that. You can also get some infiltration from things like rain gardens and grass swales or other vegetative practices. They even have permeable pavements now, which have essentially sort of cracks between them, or gravel and gravel underneath. So you can dump water on these pavements and they actually suck up water and reduce the runoff downstream. So there's a lot of kind of exciting new BMPs that are being done to try to control the runoff and address some of these problems. So yeah, just some conclusions and then in summary strategies. So we have these conflicts, both water quantity and water quality between human land uses and the aquatic environments, aquatic ecosystems. There's a lot of pollutant forms. There's a whole laundry list of them, really. We tend to focus on just a few of them. There's a lot of emerging ones which we know less about. In this lecture we focused on this nutrient pollution, algal blooms, and these dead zones. And there's a need, in order to address these, there's a big need for more sustainable agricultural practices that are, economically viable and are able to get in kind of large scale out on the landscape, and if we're going to address these issues like the Gulf of Mexico hypoxia and the Lake Erie algae blooms. As I mentioned, there's a lot of new innovative BMPs, and it's great that those are going on, and you get people involved in those to the extent possible. Every bit helps. And these are some other things that you can do to sort of reduce impact on water quality. So buying organic food products, things that reduce the use of fertilizers and pesticides tend to be better for water quality. Of course, you have to pay attention to what they really mean by that word. That word is used very generically in a lot of ways. But yeah, just starting to learn more about that, to understand how you can, support agriculture that has, is more environmentally friendly, essentially. In urban areas, you can, sweep leaves off your sidewalks and streets, which otherwise get flushed into the lakes and contribute to algae blooms. You can build a rain garden, and that's a fun project to do, and you can do for a relatively small amount of money. All right, yeah, and then just summarizing some of these strategies. Again, with surface water, trying to conserve water, reduce nutrient and sediment pollution to our water bodies, while also considering the environmental needs of, the ecological needs of the aquatic life living in the rivers, lakes, and wetlands. In terms of the, management in these agricultural areas especially, you have crop management, managing nutrients. Sometimes you hear this term 4 R's, which is right place, right time, right amount, and another R that I'm not thinking of right now. And that, we talked about the tillage practices, use of perennial plants to hold down bare soil, and promoting infiltration. And that applies often in rural areas as well, but especially in urban areas. All right, some of the resources we have in addition, if you're interested in getting more information. The Lake Erie algae video is actually required video for this section. That's a brief video from Heidelberg University in Ohio, where they talk about the processes and the causes of the Lake Erie algae blooms and some things we can do about it. There's a link to the Agricultural BMP Handbook. And we also have an extra credit video about using wetlands for water quality treatment by Bill Mitch, who's one of the leaders in that field for cleansing water. All right, well, thanks for your attention. If you have any questions, feel free to email me or contact me, and we'll talk to you later.